Welcome. My name is Brandon Waters. I'm co-president with CGIS and joined with today by Richard Laucom to go through simplifying valve maintenance with the ValvTechnologies V1-R. My pleasure working with Richard is goes way back. Richard and I have worked together for a number of years. Richard is responsible for developing technical specifications across North America for high performance severe service valves and isolation valves. He joined Valve Technologies in 2007 with responsibility for global projects, subsequently leading the design team, and now involved with developing forward-thinking vision for emerging technologies. Previously, Richard held positions at IMI in the field of fluid controls, and he graduated from Loughborough University with a Master's of Engineering and Management, holds a diploma in industrial studies, postgraduate certificate in management, and a member of the Institute of Engineering and Technology in London. Furthermore, from my perspective, one of the things that Richard brings to the industry is that combination of having designed valves, works on valves, understanding the internal workings of the product, but also being in the field and seeing real world experience of valve failures and how to fix them. And I think that that's something that is really unique in the industry here. Before we get into, so next slide there, Richard, please. Before we get into the nitty-gritty here, just a little bit of housekeeping. We really appreciate your time and involvement in these webinars that Sam does a great job of putting on. What makes them better is the questions and answers that come from them. So at the bottom of your Zoom window there, you'll find the Q&A button. Please feel free to click on that throughout the webinar, ask your questions. And we will try to get them in the moment, or if not, at least at the end of the webinar there. And then, as always, Sam will be following up with an email afterwards. And if there's any further questions or anything we can help with, happy to do that. Yeah, this one's a little bit unique. Usually we try to do an hour-long webinar. This one will be a bit shorter, about 15-20 minutes of the technical discussion around the ValvTechnologies V1-R. And then we will get to questions, but we'll see how that goes. We'll also be doing some more of the longer hour sessions in the coming weeks here as well. From my perspective, one of the things that I see in the market on a regular basis is that valves have very much become commoditized in many people's eyes. And I think we see the need when we're in the field for better performing products. There's this dichotomy between valves that are underperforming and the clients, the operators, the maintenance personnel require and demanding better performing products. One of the things that CGIS was heavily involved with was the development of MSS SP 161, which is the guideline for classifying severity of valve service conditions, so that we can really understand when to use the right product, higher performing product in those critical applications. In working through that process, we identified the need for a general purpose type valve, fit for purpose type valves, and severe service type valves. And then with each of those applications, really categorizing those by a few variables that are really important. Looking at the consequence of valve failure, what happens if that valve leaks or either through the valve or to atmosphere. If there's a serious consequence, then it's going to be more on that severe service side. Isolation requirement. Does it need to be zero leakage, or is allowable leakage something that's acceptable? And this is something that we find is very misunderstood in the marketplace. A lot of valves, brand new valves, are allowed to leak when they leave the factory. In some applications, a little bit of leakage may be okay, but we're finding that when you look at steam isolation or high, or noxious gases and stuff like that, a little bit of leakage can be very detrimental to the application. And so we'll look at how ValvTechnologies approaches that. To be able to provide a true zero leakage valve with metal to metal seated valves. Other things, availability, cost effectiveness, typical purchasing price, all have are characteristics of valves that can fall on that continuum of general purpose all the way up to severe service. And like I said, our belief is that the application dictates the valve selection, and when you need a critical valve to isolate and do what it needs to do, that severe service valves are what we look at. So in talking about that, ValvTechnologies has taken their long time experience with their V1-1 and have launched a newer development called the V1-R, which we'll get into a little bit here. But really, where it came from was again, the demands from the marketplace, where we're looking at reduced downtime. And when those valves are mechanical components, they are going to fail at some point. When they do fail, obviously we want them to last as long as possible in service, but when they do fail, we want that transition and that repairability to be as seamless and easy as possible. And that's really what the V1-R has introduced as a easily maintainable yet still high performance product that will allow us to repair that valve when it's welded in place. With that, I will hand it over to Richard to take us through how they were able to achieve that.
Thank you for Braden for the introduction and hello and welcome to everyone. As Braden talked about severe service in the world of quarter turn ball valves, we're really talking about metal seated valve solutions. So obviously soft seated valves are not really good for high temperatures, but certainly metal seated solutions would be. So the context of this would be quarter turn metal seated ball valves. And as Braden was saying, we had noticed a trend in the marketplace that had started maybe 5, 6, 7 years ago, where many end users are having to operate with fewer and fewer people. One of the consequences of that is rather than having welders on site, a lot of these folks are now subcontracted and all these costs become visible. So Valve Technologies is all about creating solutions to problems that face end users, and sometimes those problems, those challenges, changes as time goes along. So Valve Technologies looked at the market and came up with a valve that hopes to eliminate any future welding as the years go by. And the reason for all of this is time is very much money. In many plants, lost production is quantifiable, whether it's in a refinery or in a power station or in a mining application. Wherever equipment fails, the extended cost of that is very much based on the cost of lost production. This can run into millions of Canadian dollars every day for a given unit. So plants are having an increasing commercial focus, aiming to run as long as possible and to reduce the times between turnarounds. So time is very much money. So how does Valve Technologies accomplish this, especially in the world of welded valves? And so historically, there's been a couple of ways to do this. Flanged valves, even at high pressure classes, have been available. So have hub ends as well. I mean, another good way to secure valves. You have the mechanical integrity of the weld, but the convenience of a flange. But yet, many folks in the industry have not moved on from that just yet. So Valve Technologies came up with a third solution, and that's where we end up with two adapters that weld on once and only onto the pipe itself, and those adapters then actually fit to the core of the valve itself. So it's a new approach for valve maintenance. So the core itself is attached to the what we call the final welds or the end adapters. And it means that if any future maintenance is required, then that maintenance is A, quicker, B, less costly, and the time taken in that turnaround or in that unplanned outage becomes very, very minimized. So basically, we have this four-piece design with two ends, and we have like a two-piece core valve design. And what this means is that that core can be replaced in the field. The advantage here is that rather than end users buying spare parts and trying to assemble a valve in the field, all of that magic is actually taken away because OEMs have different nuances. Every OEM has their own way of building a particular valve, and maintenance technicians in the field may not have that knowledge, that secret sauce. So by having an entire core all pre-built means that the valve can essentially just slide in and be bolted into place. Because it's all supplied by the OEM or an authorized repair center, it means that any labor errors can be avoided on site. Again, a lot of these components, if they are taken out of the field, they can be sent back for refurbishment and done relatively quickly. Looking at some of the technologies involved in all these valves, when it comes to high temperature, hard facing is a key aspect. The higher the temperature, the techniques that protect against wear resistance become more and more important. If we compare two technologies, so one being the high velocity oxygen fuel approach, HVOF, as the generic term, versus something like a weld overlay such as an alloy 6, as we can see, once we hit over 300 or 400 Celsius, the this chart here shows hardness versus temperature. And as the temperature increases, an HVOF hard facing maintains the hardness better than a weld overlay such as alloy 6. And so these techniques are used in the valve technology solution when it comes to maintainability. The materials used are a chromium carbide with a nickel chromium used as the binder. This results in a very high bond strength, so about 70,000 kilopascals and over. But this technology has been around for a long time. It was originally developed in the aerospace industry in the 60s for flaps and ailerons, and then the valve industry has started to use this since the 1990s. Valve Technologies alone has over 1 billion operating hours worth of experience with this technology. So this will be standard in all the maintainable valves that we're talking about. Another technology is the ability of a valve to seal. There's a couple of ways of doing this. The way that Valve Technologies approaches this is to have ultra high forces that push the ball into the seat. So what this means is that these high forces mean that the ball itself cannot float. So we often see the term floating ball valves in the industry and also trunnion supported ones. What this approach here does is it combines the best of both worlds. So think of this as where the ball acts like a trunnion, but it isn't a trunnion because it's axially fixed because of ultra high forces applied by a Belleville spring. That enables us to offer zero leakage. So zero leakage is a step above anti-class 6. The intent here is that if any valve is manufactured or designed to a higher standard upon factory acceptance testing, then the chances it's going to last a longer time in the field actually increases. And that's the intent here.
Sorry, Richard, can you go back for one sec? Can you explain what actually fixed means?
Yeah, it's a good question. So axially fixed means that the ball shown in the blue there cannot float from left to right or right to left. The force of the Belleville spring, which is shown in the light blue there, almost the washer conical shape, is so high that it cannot float. This means that when the valve is tested in the factory, it can be zero leakage even at very low pressures because a lot of valves may depend on the upstream pressure in order for it to seal. In this case, this particular design does not rely on the upstream pressure for it to seal. So axially fixed means the ball cannot flow from left to right or right to left.
Okay, thanks.
So rapid serviceability, and this is a recent innovation in the industry. I think valves are always thought to be manufactured and designed and put into the field, but very few manufacturers have thought about the maintainability of a valve in the field. So what we have here is the central core that can slide in and out of the two adapters. It means that once this valve is in, there's no more cutting valves out of line, especially where you have complicated welding procedures such as post-weld heat treatment. We're talking about some of the alloys such as F91 or F22, C12A, for example. That process is eliminated once and for all. No more rebuilds in sight. And I think this is very unique in the industry where Valve Technologies offers a 4-year performance guarantee. So not just a 4 years parts and labor, but Valve Technologies guarantees that the valve will not leak in that length of time. And I think that for a valve that is serviceable in line is unique within the industry. So one of the questions that people might ask is, well, okay, well, how do we install a replacement core? There's many ways to do this, and this is just one recommended way, but we have a pipe spreader. So as the picture shows, we apply some clamping force via some chains on the either end of each valve. So we have those clamps. We have a tubing mechanism. So at the very, very top there, you can't see the inside, but the very, very top horizontal bar inside of that is a threaded screw. That screw is able to rotate. It is able to pull the valve apart just by enough to allow the pipe to spread, to allow the central core to be replaced. So this type of equipment readily available. This is how future maintenance could occur in the field. So what applications could this type of valve be used in? Anywhere where it's high cycle. So we think of an attemperator block valve. This is a very high cycle application where maintenance is very frequent. Valves are changed very often. So anything that's a high cycle, such as an attemperator block, would be a good starting point. Anything with a frequent throttling, such as a blowdown valve, could be another. Again, throttling on a valve that is predominantly designed to be for isolation is very, very tough on that valve. And so having the ability to maintain it in the field becomes important. HP superheated drains, as we've seen in power stations, before and after seat drains, and of course, main steam isolation, where we see steam at highly elevated temperatures. So the business model as to how it will work for maintenance is we basically started with a need to replace the V core, as we call it. So right there in the little chart, we see the starting line. A distributor doesn't have to be Valve Technologies, but a channel partner that will stock this, such as CGIS, will be able to supply the new V core. It goes to site. It means that the maintenance can be done rapidly. The original core that's coming out of the field can be sent back to a partner such as CGIS and refurbished and then returned to the end user, and then we continue that cycle. So again, by doing some of the work, quote unquote, offline, it means that we can compress the outage turnaround times. So I just want to show an animation here. It better illustrates how the valve is put together. So it's a four-piece design. So we have the two ends and the core, which in itself is a two-piece design. And as we unravel the bolts, as the animation is just about to show, we take them apart. See the gland is able to be removed as well from the very top. So the two end connections, the end cap and the body of the core valve itself. We have the body seals. It's actually a triple body seal arrangement. As we open up the core of the valve, we have one seal there in the middle. And if we look at the internals there, basically as it shows, we have an upstream seat. We have the bevel spring, and then we have the ball which rotates in a quarter turn motion. The stem is a single piece, as it's just come out there. It's blowout proof, which is why it's inserted through the ball of the valve, because it is a single piece design, as the animation has just shown us there. Put the valve back together, so we have the seal, the integral seat in the middle. All these can go back together. This is typically done by an authorized repair center. And then in line, we bolt everything back up and we're ready to go. So basically, just to summarize, this is an innovation. Many valves which are welded in high pressure applications, so specifically class 900, 1500, 2500, all the way up to 4500, where welding was the only way to go forward, then there's now another option. So flange could be an option, hub ends could be another. But to make things easy for those end users not willing to change from a welded end design, then Valve Technologies has this solution to offer, both for engineering procurement companies and end users alike. So basically, we did say that this is going to be a relatively short introduction. And so what I'd like to do at this point is open up the floor to any questions that you may have, because I think we have another 10 minutes before the session closes. So I
So
hope
one
that was
statement there
informative.
about CRNs,
Questions would be
Richard,
great.
and I think the answer is yes, CRNs for the V1-R across all provinces. Yeah, and CGIS is we've got our stock order coming in, I think next in a couple of weeks here. I think one of the things that we see is a huge potential for this, and you alluded to it, Richard, is we'll be stocking this in A105, F22, and F91. And the A105 is nice. It's readily used throughout most power plants, but where we see a massive advantages in those higher alloys, like you said, the F and P91, where the weld cost can sometimes be as expensive as the valve, and combining the fact that Valve Technologies, has the 4-year zero leakage guarantee on steam isolation. So we're already outperforming other conventional types of valves like Y pattern globes and gate valves that are often used in those vents and drains and other steam isolation application. But then being able to minimize when the valve does start to show some signs of leakage, we're not having to cut out that expensive weld and re-weld it. So I think we're gaining a lot of benefit there with those materials in particular. Does CGS have an office in Ontario? Yes, we do. We have a stocking warehouse right now in Brampton, as well as salespeople in the Sarnia area and one in Sudbury area. So definitely can help with that. We'll follow up with some information on that one. Richard, fun for you. What are the size limitations in piping
Yeah,
design?
so this design goes up to 4 inches. There's no reason why it can't go larger than that, but for now, the market pretty much is the ½ inch to the 4 inch range.
Perfect. And then another question on connection. So just socket weld, but I assume we could do socket weld, butt weld, threaded, but really the socket weld, the welded versions are the most useful for this.
Correct, yeah.
Yeah,
So it's not just the socket weld, it's also the butt weld as well. The advantage of this too is that it means that the end adapters are the only pieces that need to be machined to the specific pipe schedule if it's a butt weld or a socket weld.
right. Another good question. How is a custom welded piece advantageous over using flanges? Um, I'll let you give it a go, and then I'll add in
Yeah,
some.
the general thinking is that flanges are convenient because they can be unbolted. Many mechanical engineers, especially steam engineers, would feel safer around welded valves, and I think that has persisted. So the advantage of a welded valve is you have that, increased mechanical integrity. What the solution offers is actually both. So you have the convenience of a flange, but also the ends are actually welded on as well for those specs that cannot be changed.
I think the other thing too that we see is, a brand new build and brand new site, the flange face is always perfect in theory.
Mhm.
But on a plant that's been running for many years, you get, potentially pipe of misalignment or, the quality of the flange itself may be degraded over time. And so, um, the, that's eliminated in this design, obviously, with, once that's welded in place. There is yes, there is a connection in the body, but the Valve Technologies body gasket and connection in that those body component or um, uh, that body connection there is very strong and reliable in terms of isolation to atmosphere. Um, what should be done if there's insufficient space to install a pipe spreading tool?
Yeah, that's a fair question. With difficulty is the simple answer. I personally went around a couple of plants a couple of years ago and had a look at this because the original concept for this was actually a three-piece design. It wasn't a four-piece. And the reason why we went to a four-piece is actually precisely because of this. There's lots of areas of the pipe that are very close to bends. There might be a structural post or whatever. So the four-piece approach would make it easier than a three-piece. So a three-piece would have one end still welded, and the other end would be the one where you can, unbolt the ends and therefore detach the valve. But yes, there's going to be places where it's going to be difficult, but at the same time, there's also going to be places where it's going to be relatively straightforward.
Right. Question is about the gasket. I assume they're talking about the body gaskets,
The body seal, yeah.
different connections. So they're asking, is it a ring time joint? Speak to that, Richard.
Yeah, I mean it's a metal body seals as opposed to a gasket. So a gasket is almost like a wire that's crushable. This is actually solid. There's three of them. So we have in the core of the valve where the body and the end cap made it together, as Braden is illustrating there. We have one of these body seals, and then we have another identical body seal on each end of the valve. So that's why we have a triple sealing arrangement.
What is the length of the ball valve with two flanges on your valve set?
So the if we were to supply or manufacture a flanged valve, they will all be to ASME B1610. So all the dimensions would be identical there. The flanged design is slightly different to this, but it is fair to say that the overall length of this design that we've talked about in this webinar is longer. So it does not meet the ASME B1610 requirements. It's longer because the intent of this is to replace existing valves that are welded, and therefore you have to cut the pipe to begin with. So by having to cut the pipe and therefore to shorten it, in having a valve design that is slightly longer actually helps in the maintenance in the field.
And the last question right now, as per VCore final weld end, is a size for butt weld or and/or socket weld?
Yeah, it's for both. So basically, that final weld end has two ends to it. So one which goes onto the valve itself. So that's an interface between the weld end and the core of the valve. And then the other end could be either a socket weld or a butt weld, or actually machined to any type of weld connection. But the majority of them are going to be, the variances in the butt weld schedule.
Right. And just back to the ring type joint or the connection there, the body gaskets. With ring type joints, the understanding is that the alignment has to be very close to get a good seal between the flange and ring type flange. Um, what is the leakage potential in the field for the connections that we utilize here?
So I think when it comes to a gasket that's crushable, as what we see typically in the RTJ connections, it does differ to the body seal that Valve Technologies uses. So these body seals were developed by Valve Technologies in the 1990s. Uh, there's a lot of field experience. I mean, I don't know how many billions at this point of experience that we have with it. So we've used that same technology. We still stand behind the product and offer a 4-year performance guarantee. We say that this won't leak within 4 years. So that basically demonstrates how much trust that we have in that particular design.
Yeah, and I think that's a good point to reiterate is that the core is really standard between the V1-1 and the V1-R. It's just the V1-R has introduced that those two and a different end connection system, but the sealing mechanism between the two-piece body of the V1-1 and the I guess the three connections of the V1-R is the same sealing mechanism. And like you said, the V1-1 has had years and years of success and trouble-free. We just one of my sales guys out east was looking for one of our case studies that we did on replacing some vents and a vent valve at one of the pulp mills out on the west coast here, where they had been using Y patterns and having to cut them out every shutdown every year. And we put a ValvTechnologies V1-R in there as a trial, and it lasted 25 years, zero leakage, before it finally had to get pulled out. So um, I think our approach and our mentality, even with the V1-R, is that we want to put in a valve that's going to last a lot longer than what customers are used to. But then having that ability to use it more as an asset than a commodity. And like I said at the beginning, I think too often valves have become a commodity and replace in kind and just throw them away. And I think our mentality and our goal for world valve problems is to put in valves that are going to work, and then when they do, like I said, when they do eventually succumb to leakage, that we can repair them and get them back up and running as fast as possible.
See one more question there, and question is on HP superheated drain application. What is the maximum temperature the internals can handle? Actually, it's the same as the body material. So if we're looking at carbon steel, then 800 Fahrenheit is the absolute maximum. I mean, we see most applications about 725, so about the 400 Celsius range. And if we're looking at the alloys such as F22 or F91, and of course that goes even higher to 1200 Fahrenheit. So basically, answer to the question is the internals are engineered to match the maximum working temperature of the body material.
Perfect. Well, no more questions. We're 2 minutes over our allotted 30 minutes, but that's a pretty good job, Richard. I appreciate that. Thank you, everybody, for your participation. The question, great questions. Love that. Like I said, Sam will be following up this webinar with a email. If there's specific applications you would like to look at, we'd be happy to work with your team to get those quoted. Like I say, we got our inventory coming in, so happy to get some trials if you'd like and hopefully get closer to a world without problems. But with that, we'll let everybody get back to the day. Richard, thank you so much for your time.
You're
Sam,
welcome.
thanks for hosting as always, and have a wonderful rest of the week, everyone.
Thanks, everybody.